Okay, so guys, let's take a look here. This problem here is real similar to the one that we had done on Tuesday night. Okay, so if you notice, instead of talking about cars being sold, looks like we're talking about overtime hours, right? So let's take a look at our overtime hours. And so we're looking at either working 0 overtime hours or 1, 2, 3, 4, 5, up to 6, right? So let me ask you a question. Do we know how many employees we have right now? All those, right? Do we have 6 employees? No, those are the number of what? Hours, right? Because it tells me right here, guys, if I look, this tells me the hours, right? How would I figure out how many employees we have total? We would add them up, right? Okay, so what numbers are we going to add? Good. So we're going to add those numbers 6 and 12 and so on and so forth. Okay, so let me get my calculator over here. Let me first turn it on. Okay, let me clear it. So let's do that. Okay, so we're going to take 6 plus, what, 12 plus, still there, yeah. 29 plus, what is it, 57 plus 42 plus 30 and one more, 16. So we have a total of how many employees? 192. Okay, so right here, guys, I'm going to write total 192. Okay, so I want to kind of do what we did on Tuesday. Let's see if I can get this over here. Okay, so guys, if you remember on Tuesday, one of the things that we did is we already had another table somewhere over here, right? And the numbers that I'm going to put across, I'm going to put numbers like 0 and 1 and 2, 3, all the way to what number? 6, right? Okay. Let me go a little further. That lets me, there we go. Okay, to 6. Okay, so then guys, the next thing we need to do is we need to figure out our probabilities. So we know the total is what number again? 192. Okay, so remember what we're going to do here, guys. I'm going to take the first one here is going to be 6. And I'm going to write it as 6 over 192. And then I'm going to figure out what that is in my calculator, right? So can y'all do me a favor? What's 6 divided by 192? Okay, so guys, I'll tell you what, let's try to be consistent. So let's go to 4 decimal places. So my question to you is, if I was going to write 4 decimal places, what numbers would I write down? 0.0 what? 313. Okay, so let's do this real quick. Let me erase this mess. And right here, I'm going to put 0.0. You said 313? Okay, guys, we're going to do the same thing for the rest. Okay, so can somebody do me a favor? What is 12 divided by 192? And let's go again, 4 decimal places. I'll give you a hint. Point something. 0.625. Okay. And let's do the same thing, guys. What's the next one we're going to divide out? 29. Oops, let me come back. Okay, so then we're going to go 29 over 192. So point what? Four decimals. So what number are you getting? 0.1510? Good. Okay. The next one, guys, should be what? 57? So what's 57 divided by 192? Point what? Don't be scared. 2967. Thank you so much. Okay, and Fred, I got a handout for you right here. Okay, guys, the next one should be 42. 69, okay. It's all right, we'll fix that right here. We'll come back, 69, good, okay. And then, let's see, the next one would be 42. What's 42 divided by, what was it, 192? What number are you coming up with? 218. So if it's 75, would I go 88? Okay. And then, guys, the next one would be 30 divided by 192. What's 30 divided by 192? So 0.1, I'm sorry, I just didn't hear you. 1.6. If it's 2.5, could we go 6.3? So So we can go again 4 decimal places. And then the last one, guys, what's 16 over 192? Point something or another. 0.0833. Okay, so look, now we have our probability distribution table, right? Okay, so then we're going to come back and we're going to take a look at part A. So if you notice part A says, find the probability of 1 or 2 hours. So guys, aren't I just going to take the first number, which is 0.0625, and we're going to add what other number? If it's 1 or 2 hours? 0.1510, right? Okay. All right. So then I'll come back and I'll grab my calculator, right? Let me clear this out. And let's see. And so I'll put 0.0625 plus you said 1510, right? Oops. And 0.2135? Okay, cool. Okay, so there you go. Okay, guys, let me ask you a question. If we were going to do 2 hours or less, what numbers would I add up if I wanted to do 2 hours or less? The first 3, right? So 0.0313 plus 0.0625, and then plus what, 1510? Okay. Anybody know what you end up with? I'll give you a hint. Point something. Right? We know it's going to be point. I'm sorry? I did 2448? Okay, there we go. Alrighty. Guys, look at part C, right? Part C says between 3 and 6 hours inclusive. So remember what the word inclusive means, right? Inclusive means we're going to include the numbers 3 and which one? 3 and 6. So wouldn't we take 0.2969 plus 0.2188 plus 0.1563 and then finally 0.0833, and we would add those numbers up, okay? And what do y'all come up with? $75.53. Good. Okay, guys, are these problems making sense as we're going through them? So far, we're doing okay? All right, good. And let's see. Oops, not that much. Okay. And then look at part D. Part D says between 1 and 3 hours inclusive. What numbers would we add up? If we're, these right here, right? So we're going to take 0.0625 plus 0.1510 plus 0.2969. I'm sorry, how much? That's too much.
0.5104.
There you go. Okay. Guys, think about it this way. My probabilities, the biggest that my probability would ever be is 1.
And only if you state there or round to a decimal or round to the whatever is when we're going to round it. Now it's plot out the whole.
Yeah. And so when you're doing your homework, it's going to be very specific. It'll tell you round to 3 decimal places or round to 4 decimal places. It'll tell you what to round to, right? So that's why when we did this problem here, when we were coming up with our numbers, remember, guys, we took each of those numbers like. Well, hold on, wait. Before I go to the off-topic one, just to make sure we know what we're doing. Remember, guys, the way we came up with these numbers here is we took 6, 12, 29, 57, 42, 30, 16. We took each of those numbers and we divided them by what? By 192, right? And that's how we got our numbers here. And I said, let's just round it to 4 decimal places, right? But in your homework, it'll tell you what you need to round to. Fred, you had another question?
Just in the when you are looking for the deviation where it's squared. So do you round then square it, or do you square it then round it?
So what I would probably do, I would probably put point and maybe 2 or 3 decimals, and then square it, and then from there you're going to round, right? But I would never say, let me just do point and take the first number. I would take a couple just to make sure. Think about it this way: the more that I start rounding, the bigger my error is going to be, right?
Last homework said the first decimal.
Yeah, so it said to the first decimal.
One of them I saw was like 0.955, and I was like, okay, so do you round that up to 1 as a whole?
Yeah, and my math lab has what's called like a little tolerance. So what it'll do is it'll say, if you say the answer was actually 0.9, but you put something like either 0.9 or 1, it'll give you credit for either one of those two, right? But if you put something like 7, okay, man, you're way off, right? Yeah. Okay, so guys, the next part here says at most 4 hours. So what does at most 4 hours mean? What does at most 4 hours mean? 0, 1, 2, 3, 4, right? That's what at most 4 hours means, right? So 0 through 4. So I'm going to come back over here. Let me see. 0 was 0.0313. What was 1? I'm sorry? 0.625, right? There you go. And then plus 1510. And then 2969. Is that the last one? We need one more, right? 2188. Good. Okay. So guys, we're going to add up all those numbers together. 976. You said 05? 05. So guys, if it's 0 and then 5, there's another 9? Oh, I'm sorry. My bad. Sorry. 0.76? 05. There we go. Thank you. Sorry about that, guys. Okay. And boom, there we got it, right? Okay. So this problem, guys, you can see, I mean, I was using my calculator, but I wasn't using all the features that we've been using so far, right? So let me try going. I think it's on your next page. And let's see. Here we go. Okay. So this one here, guys, I am going to use my calculator. And so the first thing it says is, let's find the mean, the variance, and standard deviation of the probability distribution. Okay, so guys, first thing I'm going to do, I'm going to grab my calculator, okay? And the one that I have right now on this computer, guys, is the 83 plus. And if you have like an older 84, this will work exactly the same way. If you have a newer 84, it'll work slightly different, and I'll show you how to do that right now. So guys, remember the first thing we're going to do, we're going to go to stat, right? Then we're going to go to edit. Okay, what numbers should I put for my list 1? Okay, so this works. 4, 5, good, this works easier. 7, 8. Okay, and then I'm going to go over to list 2, right? What numbers am I going to put for list 2? 0.188, right? And then 0.223, and then 0.214, 0.348. Oops. Whoa, I didn't want to do that. Delete. And delete. There we go. And then finally 0.027. Okay. And enter that one in. Okay. And then guys, I'm going to come back to stat, right? And I'm going to go to calc. And I'm going to do one variable stats, right? Okay, so guys, if your calculator looks like this, remember the first thing I'm going to do? I'm going to open up my parentheses, right? And then I'm going to hit second L1, right? And then comma, second L2, right? I'm going to close it off. So far, we done okay? All right, guys, let me ask you a question. Does anybody's calculator not look like this one here? On your calculator, when you do your one variable stats, does it come out like that, or does it come out differently?
A little bit different.
A little bit different, okay. So then, this is what we're gonna do. Let me see, clear this out. All right, so let's go stat. Oops. Stat. Let me go to my list. Okay, so we said it's 4, 5, 6, 7, and 8. And then the other one is 0.188, 0.223, 0.214, 0.348, 0.027, like that, right? So then, guys, just to show you, if your calculator looks slightly different like this one, then I'll come back to stat. I will go to calc. I'll do one variable stats. My luck, it's doing the same thing. Let's see. Here we go, stat, calc, one variable stats. Here we go, this one should do it. There we go. Okay, so guys, if your calculator looks like this, you're going to put list 1 under list. Under frequency, you'll put list 2, and then you hook calculator, right? I don't want to do it because my numbers are probably different. I don't know what numbers are in here right now, right? But then all I'm going to do, guys, is let me switch back over. I will hit enter, okay? So remember, there are a couple things it's asked me to do. It's asked me to find the mean. Okay, do y'all remember which symbol is for the mean? Out of all those up there, which is the mean one? The X with the little bar, right? Okay, so the X with the little bar is going to be my mean. So I'll write 5.8, okay? So right here, X with my bar is 5.8, okay? Now, let's take a look and see, okay, before I do anything else, what is this problem even telling me? Well, let's take a look. We're talking about what? Talking about baseball. And we're talking about the number of games in each World Series from 1903 and through 2016. So the number of games played in every World Series from 1903 until 2016, on average, how many games were played? 5.8, right? Okay, so we would probably say something like it's probably closer to how many games? 6 games, right? Okay, we could say something like 5 or 6 because it is 5 point something, but you know, we're just trying to get sort of an idea here. Okay, then the second part is what does this mean? Okay, well, number 1 tells us we had about 6 games per World Series. The other thing I want to find is my standard deviation and my variance. Okay, so guys, I'm going to come back to my calculator. Which is my standard deviation here? The O with the little hat, right? That's the lowercase sigma, okay? So if I was going to go with the O with the little hat, suppose I decide to go to 2 decimal places. What number would I write with my O with the little hat or the sigma with 2 decimal places? 1.18, right? Okay, so I'm going to come back over here. My standard deviation is 1.18, okay? So, guys, before I do anything else, remember what the standard deviation tells me. The standard deviation says, well, my average was about how many games? 6 games. Most games either had one more, because this number, if I rounded to the nearest whole number, would be 1. Most games either had one more game or one less game. So that's telling me if there was an average of 6 games, most of the World Series either had 6 or one more would be what? Or one less would have been that. Does that make sense? So with an average of 6 games with no more than one more or less. Does that make sense? Okay. Now, we're also going to find the variance. Guys, if we know what the standard deviation is, how would we find the variance? Square it. So remember, all we're going to do now, square it. I'm going to take my calculator. We're going to figure out what is 1.18. We're going to square it. So yeah, let's see.
The deviation will always be the same, right? Plus or minus?
Yes, that's right. 1.18 squared and 1.39? Okay, so guys, this is what Fred was asking me earlier, right? Is it going to tell me to round? It'll tell you to round. It'll tell you what number to round to, right?
But like, even from the beginning, like the circle with the hat,
Uh-huh.
you rounded it up.
I rounded
If
up.
you would have not rounded it, then squared.
Yeah, but let's put it this way. I wouldn't want to just put 1.1. You see what I'm saying? I don't want to just put 1.1 because I'm already cutting off. Look how many numbers we would be cutting off if we decided to go to 1.1. We're taking out the 7, the 9, the 1, the 1, the 4, the 3, the 7. All those numbers actually are going to affect my calculation, right? So what I'm saying is I don't want to just say, let me just put 1. Or maybe I should just put 1.1. I would always say, let's go at least 2. I know
it was asking for 3 decimal places, even like from 3 to 1, right? Like
right.
So then that's where I get confused.
So
this number has 3 decimal places. Do I square with the 3 decimal
yes,
places?
square with the 3. So if it asks you what's the standard deviation, and it tells you, if it tells you for the standard deviation, just put 1 digit, then you can go ahead and square that number to find your variance. But if it tells you for your standard deviation, put 3 decimal places, that would be the number that I would tell you to square, right? So like in this problem, Fred, suppose the direction said, let's go to 3 decimal places. If I were to go to 3 decimal places, 1.7, wouldn't it still be 1.80, right? If I were to go to 3 decimal places, guys. So I want you to look at this number right here.
But we type it out as 1.179.
But hold on, wait. Look at this number here. Are you going to leave that as a 9? Or are you going to round it up? You're going to round it up, right? So if you round this guy up, doesn't it become 1.80? You see what I'm saying? Okay, isn't that really the same thing that we have right there? Because you can do this, and you can do this, and it's not going to change it, right? My whole point is, if your original problem told you write your standard deviation with 3, then when you're going to use your variance, that should be the number you're scoring, right? If you start rounding it off, you're going to get what we call round-off error, right? So guys, when we squared it, what number did we come up with? I know we had it up there, 1.39. And okay, let's just put a third one. What would it be? 1.39 what? 1.392, okay? Again, it'll tell you what to round to, but my whole point is if it tells you on standard deviation round to 1, then you go ahead and square that number. If it tells you round to 3, square that number, okay? All right. Okay, so guys, before I do anything else, what I want to do is I want to come back to our notes from 4.2 that we were working on